So in this video, we're going to take a look at arithmetic series. And an arithmetic series is to add up the terms of a sequence. So, in my previous video that I made, we looked at the idea that there's a sequence that is like 5, skip counting, 5, 10, 15, 20, and 25. And so that is a sequence of adding 5 to each term. But the series would be to add these numbers up, specifically in identified ways. Like if I add the first 2 terms up, that's a series of term A1 and A2. If I add the first 3 up, that'd be a series of terms 1, 2, and 3. So the definition of a series is that it's a sum of a sequence between 2 identified terms. So an example of what I'm talking about there is if I said find S of 5, that would mean find the sum of A1 through A5. So that's asking me in the example I gave earlier to, instead of just writing them out, to actually add them all up. And that would look like this, right? So instead of having commas between the terms that we had originally, this would add up term A1 through A5. And if you add all these numbers up, you would get 75. So the sum, and actually the way you would write this is the sum of the 5 terms of this sequence is equal to 75. Now, it's important to understand that math has a lot of just important language here. So the sum of 5 terms means to add these up. So I don't need to actually, this is the work, and this is how the answer would be written. Okay, the sum of the 5 terms of this sequence is 75. So if I say, well, what is S of n? S of n is actually a formula that could do this for me. So instead of iteration, which is iteration is to write them all out, there's actually a formula you could use to do that sum without having to write them all up and add them all down. I'll add them all up and write that down. It could also mean the final sum, meaning S of 5 is actually the final answer for here. It's actually S of n. So it could mean the final sum of a particular question. Now, the letter S looks different in other languages. So sometimes you'll see this letter, which is the Greek letter S, which means to sum as well. And we'll take a look at that more specifically in some examples. So if you ever see this letter, it's the Greek letter, and it also means sum, and it has some very specific things that it will do. Like, for instance, here it says add up 5. But what it would do here, the exact same thing, if I use this notation, is it would say n equals 1, and then it would actually put the 5 up here. And so this very strange looking thing says the same thing as this does. This would say find the sum of 5 terms. But instead of writing it like this, we would say n equals 1 to 5. And this is the universal math word for sum. Obviously, if we were in a country that didn't have S's, that would be confusing. So the universal letter used for sum is the Greek letter S, which is called sigma. All right, so the formulas that we're referring to, because remember it talks about a formula here, there's 2 of them. One of them is that the sum of any terms is equal to n divided by 2, a1 plus an, a1 being the first term, an being the last term, just like they were in the previous video. N over 2 means take the number of terms you're adding and divide that by 2. So like if I was looking at this example here, that would be 5 over 2. And a1 would be 5, and then an would be 25. So let's just take a look and see if the formula works. So S of 5 would come out to, I'm adding 5 terms up. A1 was 5. An was the last term that I had, which was 25. Okay, and so that will give me 5 halves times 30. And if you do a little bit of reduction here, just by saying that and that make 15, you get 5 times 15, and 5 times 15 is 75. So that formula will do the exact same thing for us as writing them all out, which is amazing. If you had to add up 100 of them, this formula would be the way to go. There's also another formula that looks longer. And this formula is what you use when you don't know an. Notice in this one, you have to know the last term, which I knew it just because I iterated it. Think about that. So it's kind of ironic that I had to iterate it to be able to do the problem. There's another way to do that, which I'll show in examples. But in this problem, I could actually get the answer without knowing the last term. So let's see if that would work. So here we would have 5 over 2. Then we have 2 times a1. a1 was 5. Keep in mind that n in this problem is 5, right? Because we're adding up 5 terms. Remember, to keep that in perspective, I'm just going back to the beginning of these notes, which said find 5 terms. And then we subtract 1 from that, and then we multiply times d. And so d in this sequence was we were adding 5. So if you simplify that, you will also get 75, which is really cool. Let's take a look. So what happens here is we get s of 5 would be 5 halves, and then I'm going to simplify everything in the bracket. So this would be 10, and this would be 4 times 5, which comes out to 30, right? Because this is 20, which is the same thing I got over here, and I'll explain why in a minute. So s of 5 again comes out to 75. So why would you have 2 formulas? Well, this formula is more compact and is very useful if you know the last term. Sometimes they give it to you, so you use this. If you don't know the last term, you use this longer version. And the longer version is actually what happens if I were to plug in what an is from the previous notes. So an, we learned, was actually equal to a1 plus n minus 1 times d from the arithmetic sequence notes. And if I plug that in right here, I'll have a1 plus a1, which is 2a1, and then I have my n minus 1 times d right there. So it's actually the same formula with this right here in replaced for this. So you scratch that out, you put that in there, and you combine like terms, and you get that formula. Just remember this, that an and a1 is the formula you use if someone gives you the first and last term. If you're not given that last term, you use this formula. And we'll look at examples on that momentarily, but it's just really important to understand the difference here. I know the last term, I don't know the last term.